Hey everyone, welcome to this channel, Sci-Fi. So today we are going to talk about the questions as per the UPGDC Assistant Professor exam. So here you can see the questions will contain the introduction, body, okay, and the conclusion. So here are the few questions we are going to talk about, and it will contain of multiple topics. So let's start from the electrostatics. Okay, the first question. First question says that under one-dimensional configuration, the charge density is given by rho x, which is rho naught x by 5, where rho naught is a constant charge density if the electric field E is equals to 0 at x equals to 0 and potential V is equals to 0 at x equals to 5. Determine the Vx at the end electric field. Okay. So here actually I have colored the like Gauss law and divergence of electric field is equals to rho upon epsilon naught. So, what are the important things which you have to highlight, okay, in the questions while you are writing the answer? Okay, okay. So, this is how you have to highlight the important aspect or the part of the answer. So, here the introduction is defining that it is about the Gauss law, okay, and its formula is defined and it is the integral form, okay. You can show there and this figure you can make. The figure must be small, okay, but not that much small कि वो दिखे ही नहीं, okay, but sufficiently enough so that it is visible and clear to the examiner. Now the equation in the one dimension, it is d upon dx, which is equals to rho upon epsilon, where rho is the density, volume charge density, which is depending upon the x, and the potential relation with electric field is given by this, that is gradient or the divergence of potential with respect to x. So in the body we have the first part, that determination of the electric field. So what we have the formula, that density we have the formula, we will put and the integrate, and we will use the boundary condition which is highlighted here at the therefore, and the constant c is equals to 0. So we will have the electric field where density rho naught is equals to 0, so that we will get the electric field. Now the second part is determining the potential. This formula, that is the electric field is negative gradient of potential. So on the basis of that, we will have the electric field. What we will do, we will integrate here, apply the boundary condition, and we will get the final potential here. And the conclusion is that there is electric potential and the field is gonna, this is the potential, this is field, and field where the volume charge density rho naught, it is greater to the 0. So this is how we will have what we are going to have in the like whole PDF, at a pattern that we will have introduction, we will have some kind of figure, we will highlighted the important things, okay, and we will have body and defining all the steps and going to the conclusion. Now moving to the second question, it is also from the electrostatics. It is about the conservation of the field. So the question is, define a conservative field, determine if the field given below is conservative in nature. So electric field is given, okay, and okay. So the introduction is mentioned that it's for the conservation, okay, means that it is path independent, which is highlighted here. The mathematical form, that is curl of E is equals to 0. So अगर हमने इसको mathematically, if we have proved this thing, so we can say that the field is conservative. So in the body part we will have like we have taken the component ex, ey, ez, have taken the curl. So we get the curl is equals to 0, hence the field is conservative. So it is a simple question, but the main thing is that the pattern, how you have to present and write the answer. Introduction, body, which will have multiple steps, and the important things must be highlighted. Okay, and the finally we'll have the conclusion. Now moving to the next question, it is from the special theory of relativity, addition of velocities. So the question is, prove that the addition of the two velocities cannot exceed the velocity of light in space. ठीक है. So classically it is defined that velocity v is equals to, if we have two objects moving in certain direction, so it will be directly added, okay, if they are in the same direction. So here we have to prove this thing, that addition of two velocity cannot exceed the velocity of the light. So in special theory of relativity, we know that addition of velocity formula is given by this, that is v is equals to, or you can see here that v is equals to u plus v upon 1 plus v u upon c square. So in this relativistic case, we consider what, that our u is also less than c and v is also less than c, that is the speed of light, c is the speed of light. So here u is the speed of the frame s dash, this is s dash frame, okay, and v is the speed of the particle. Here we are considering everything along the x direction, so v is the velocity along the x direction. So this is all the introduction. Now we'll move to the body part. This is our body part. So here what we do, the questions demand is that addition of the velocity in the relativistic condition must be less than the speed of light. So we have say that, okay, let we consider that u is less than c, v is less than c, then the addition, that is the v, okay, it must also be less than c, okay. Now it is our, like, condition we have considered, and this must be proved, okay, this thing. Now what we have done, that we have simple formula. Now we are doing some mathematics, so we will get this reduced form, that is c minus u, c minus v, which is greater than 0. Now since we have considered that c is greater than u, c is greater than v, so therefore if I take q on the left side, so I will get c minus u is greater than 0, and this condition c minus v is greater than 0. So this shows that this whole thing will be greater than 0. This is proved. So we can say that what we have initially considered, that v is less than c, so this is satisfied. So we can say that addition of two velocities, it will always be less than the speed of light. In the limiting case, if my v is tending to c, so it will be, can be equals to c, but cannot be more than c. In classical case, where v is very much less than c, so in that case we will get the same classical condition what we have initially, v is equals to u plus v. Okay, so the conclusion is that u is less than c, v is less than c, it necessarily gives v is less than c. So this is kind of pattern you have to follow. Okay, first there's introduction, some highlighted part, some like figures, and then proof or the body part in a step ways, and if there is some condition you can mention if you have sufficient page left, and then the conclusion finally, and highlighted the what will be the result, what is the result. Okay, so the next question here is, uranium 235 is required per day in the nuclear reactor of 2000 megawatt power. Okay, so it is generating 2000 megawatt power, and its efficiency is 60%. Assume the energy released per fission is 200 MeV, mega electron volt. Okay, so there's introduction that its efficiency is something less than or everything. Okay, so here is the nuclear chain reaction, in which when we get a neutron to the uranium 235, it will break, release energy, that is 200 MeV, and further three neutrons will be produced, and these neutrons will go, like, interact with the other 235 uranium, and the chain reaction goes on. So this is the introduction which you will have to introduce. Now the body part, given data is that electrical power this much, that is 2 into 10 to the power 9 watt. Efficiency, that is zero point 0.6, that is 60%. Okay, and energy release per fission, that is 200 MeV, and total time, or in terms of seconds, it will be 86,400 seconds per day. Now, so here we will find out that efficiency means what here, that the amount of energy generating per fission and converting it to the electrical form is only the 60%. Okay, what we are using, what we are getting in the output is just a 60% or 0.6 times the energy produced. So here the efficiency formula, that is electrical power to that of the thermal power. So from here we will find out the thermal power, which will be 3.33 into 10 to the power 9 watt. So this is the thermal power, and next we will find that the thermal energy produced in one day. For one day thermal energy, we will multiply that number of seconds, that is at 6,400. We will get this much amount of energy, which is of the order of 10 to the power 14 joule. Now we will convert this energy, that is energy released in one fission, in the joule. We'll get that is 3.204 into 10 to the power minus 11. Now number of fission required per day. Next thing. Okay. So for that, what we'll do, we will divide. Okay, what we will divide, the this energy and this energy released per day, energy released per fission. So we'll divide, we will get the number of fission per day. This is the amount, 8.99 into 10 to the power 24 fission per day, to generate that 2000 watt of the power. This is the 2000, sorry, 2000 megawatt of the power per day. Now to find out the mass it consumed to produce the 2000 megawatt of the power, what we'll do, we'll divide number of fissions per day by the Avogadro number, which will define the number of atoms which is going to fission. Okay, uh, and multiplied the amount of the uranium 235 in the, it is the atomic mass, and we multiplied, will get the result, that is equals to 3.51 kg to produce the 2000 megawatt of energy per day. Okay, so this is the answer. This is how you have to highlight the answer, and this is the way, a proper way, how you have to write the answer. Now, moving to the next question, it is from the quantum mechanics. The question is, calculate the location at which the radial probability density is maximum for the ground state of the hydrogen atom. So in the body, it is defining the hydrogen atom ground state. For the ground state, n is equals to 1, l is equals to 0, and m is equals to 0. So psi n l m for the radial wave function is given by this 1 upon under root pi a naught cube, and it is multiplied with e to the power minus r by a naught, where a naught is the Bohr's radius and its value is defined by 5.29 into 10 to the power minus 11. Okay, for the radial probability, it is the formula, it is given. This is 4 pi r square mod of psi r function square dr. So for the maximum probability, what we will do, we will differentiate it with respect to r. So from the differentiation, we will get, we will equate it with 0, and we will get r1 minus r by a naught. From here, we will get r is equals to 0 and r is equals to a naught. That is two values. Since at r is equals to 0, since we know that in the atom, electrons radius is considered from the nucleus, so we at r is equals to 0, there is a probability of presenting of electron is 0. So the maximum possibility is that r is equals to a naught, is the possibility where the electron can be. So here in the conclusion, we will write that the probable radial distance of the electron from the nucleus in the ground state of the hydrogen is Bohr's radius, which is R max is equals to A naught, which is equals to 5.29 into 10 to the power minus 11 meter, or 0.529 angstrom भी लिख सकते हैं. Okay, now moving to the next question, and it is the last question for the day. So here the question is, what is the field effect transistor? Bring out the major advantages of using field effect transistor over a bipolar junction transistor. Now the introduction is that field effect transistor is a three terminal and so on. You can read here. So it is all explaining the FET, and it have source, drain, gate, everything. And this is the picture of NPN BJT, PNP BJT, and comparing with the JFET. This is N channel, this is P channel. It is also of two type. Its working is defined here. Now the main thing is that this is the all introduction working principle of this field effect transistor, and the major advantage of FET over BJT it will have, we have to write in point wise, like very high input impedance, low power consumption, voltage control operation, better thermal stability, low noise, high switching speed, small size and easy IC fabrication, and high input output isolation. These are the point here. There is a tabular comparison. It is not very much necessary in the question, but here from here you can get some points right in your answer. And this is the conclusion, and that's all from my side.